So let's see what you said so far. The supermarket sells 1 kilogram bags of grapes. Does your supermarket do that? Do any of you shop at the supermarket? A couple of you do? Okay, maybe your parents do it for you more often, but when you go to the supermarket, they don't generally sell 1 pound bags of grapes or 1 kilogram bags of grapes because it's so hard to get them exactly there. Like, what are they going to do? Like, pick off the grapes until they're as close as possible to 1 kilogram? But in this case, they're telling you that this supermarket is selling 1 kilogram bags of grapes. And do you expect that they would be exactly 1 kilogram? No. Like, honestly, even if they were like slicing grapes in half, they couldn't get to exactly 1 kilogram. So I think no is a reasonable answer. Raise your hand if you can share a range of weights that you think that the bags of grapes might be. I see one hand. I know more than one person answered. 2 hands. 3 hands. All right, Lily, will you share your answer? All right, 0.5 to 1.5. And then, Simon, what was your answer? Okay, so we were just sharing. Simon, what did you say was your range? 1 to 1.5? And then, Sophia, what was your range?
0.9 to 1.1.
Yeah. So you would hope with their quality control that they would have something more like 0.9 to 1.1, but even that would be hard to do. So it might be more like one of these. All right, next one. Adriana weighed 50 bags of grapes, which were delivered to the supermarket in 1 day. Do you think that this sample would be representative of all the bags of grapes sold by the supermarket? Explain your answer. So I'm just going to quickly get your answers with yes or no to start. Raise your hand if you said yes, that those 50 bags would be representative. Okay, raise your hand if you said no, that they wouldn't. So what would be a reason why somebody might say yes? Go ahead.
Because 50 bags is a big sample size, so it's very representative of like a big group of them.
So it's a big sample size?
Yeah.
Okay. So it is a big sample size. Very good. And what would be a reason we could say no? Raise your hand if you could tell us a reason why we could say no. A lot of you said no. Go ahead. Right, so maybe not big compared to the total amount of bags. Mm-hmm. All right. Any other reason why this might not be representative? Go ahead. It was all on the same day, right? So, like, if you look at grapes or blueberries or some sort of fruit at the supermarket, there's often more than one place it comes from. And, like, when I look at blueberries, one day they've all come from this one farm, but then if I look 2 days later, they've all come from a different farm. And so perhaps, like, because they're coming on different days, maybe that would also make it not representative. So also maybe not. So honestly, I didn't really have a favorite yes or no answer here, just as long as you gave me a reason. All right, what kind of graph should Adriana use to display her results? So I want to hear all the ideas. Sophie, what was your idea? Line of best fit. What would be your X and Y? Okay. All right, what would be another kind of graph we might use? Kaden.
I don't think many types of graphs.
Uh-huh.
Instead of bar graph,
Could be a bar graph.
the I could possibly being like the weight and then the X being like the number of grapes and then the Y being the weight. specifies how many grades are certain.
Okay. So we've got bar graph, we've got line of best fit. What other graphs might they be? Any other ideas? Okay. What would you expect Adriana's graph to look like? So did you guys think about that? If you were making, for example, say we made a bar graph and we had, over here we had the number of bags with that weight, and down here we had the weight, right, with 50 pounds in the middle. So like, let's say that's 50 pounds there in the middle, 50 kilograms. Oh, 1 kilogram. 1 kilogram is in the middle. So this is how many would have a weight of 1 kilogram. What would you expect on the sides? Would they be taller or shorter? They'd be shorter, right? So like, say it again, like a bell curve? Oh, who else was thinking bell curve? That's a good thing to be considering here. So you think about it, most of them are going to be around the right weight, and a lot of them are going to be really close. But as you get farther and farther away from the weight, there'll be fewer and fewer bags, you know, that would have like that kind of difference. Until you get down here, like very few bags would have, you know, a big difference from what you would expect them to be. So maybe something like that. And that's actually not a bar graph that I drew. Does anybody know what I drew? Histogram. How's a histogram different from a bar graph? The name. The bars are touching. That's right. In a histogram, the bars are touching. And there's a reason why they're touching. We'll get to that. Okay? All right. Any questions about the warm-up? I didn't actually give you much information. It was mostly you guys starting to think about it. I took your answers. All right, let me switch out of the pencil because obviously that's hard to read. And I'll move on. Okay, so we're going through a lot of vocabulary today. Bear with me, but if you feel like you need an example of like, sometimes when a lot of words come at you, if you feel like you need an example, just raise your hand and say, hey, could you give me an example of what you're talking about there? Okay? All right, so we're talking about actually our new topic, which is topic 21, statistics vocabulary. And we're going to start down at the bottom. 21, statistics, vocabulary, data. Some people say data. You notice some people say data, some people say data. I'm a data person, but you can say it either way. Information about the characteristics of a group of individuals. And individuals could be people, or the individuals could be like bags of grapes, right? We have different types of variables that we measure with statistics. We have categorical variables, which describe a particular characteristic. Which can be divided into categories. All right, so say like I wanted to split you all up depending on what type of shoes you're wearing, right? And so like I'd have all the Converse, you go to that corner, all the Vans, you go to that corner, all the Uggs, you go to that corner. All right, those would be categories there. Quantitative variables describe a characteristic which has a numerical value. So for example, if I wanted to split you up by your height, I said, okay, everybody under 5 feet over here, 5 foot to 5'6" over here, 5'6" to 6 feet over here, over 6 feet over here. That would be numerical, and so I'd be splitting you up that way. Population. Population is the entire collection of individuals. So that would be if I was gathering information from you all, but I wanted to use that information to make conclusions about a larger population, like Southlake students. Like I wondered what % of Southlake students wear Vans. And so I surveyed you guys and then I use that information to make a conclusion about an entire population. So an entire collection of individuals about which we want to draw conclusions. All right, turning the page. Census. Every 10 years, the United States holds a census, and in that census, they try to count every person in the United States. They don't just count the people in Maine and then multiply by 50, right? They count every single person. So a census is when you collect information from the whole population. Collecting information from the whole population. A parameter is a numerical quantity measuring an aspect of the population. So if I wanted to know about the US population, I wanted to know what percent of the US population smokes cigarettes. Then I could, probably I would take a sample, or I could use the census. And then I would find out this parameter, this numerical quantity about the population. A sample is when you select people from the population to ask. So doing a census is really hard. That's why they only do it every 10 years. So usually when they're trying to survey people, they take a sample. So a sample is a group of individuals selected from a population. And a survey is the collection of information from a sample. A statistic is used to find a parameter. So the statistic is the quantity calculated from the data gathered from a sample. And it's used to estimate a population parameter. So if I went to the Reston Town Center and I asked every 5th person I saw, do you smoke cigarettes? And I used that percentage to tell me about American people in general, I would be using a statistic to calculate a parameter. All right, we have 6 steps of statistical investigation. I want you to take a short moment to preview that, and then we'll fill in our blanks. All right. So here's your 6 steps. State the problem. We need to decide what we're investigating and describe it exactly. We need to decide which variables we can measure. Variables. To help us understand our topic of interest. Oh, do that all the time. Then we're going to choose a sample. So there are different ways of choosing a sample. Some ways are better than others, and we're going to talk about that in a minute. If I wanted to know about all Southlake students and I asked just you guys, it might not be a good sample because you guys are mostly all in the same grade and you've taken mostly the same math classes. So you might not be a good sample of the entire population of Southlakes. There are other ways of sampling too. I could do a random sample where I just chose people's ID numbers randomly. And that might be a better sample. There are others too we'll talk about. So in general, it's impossible to obtain data from every single individual in a population, so we need to choose a sample which is representative of the whole population. So then we collect the data, and it's important to ensure that the data we collect is going to be appropriate or useful. And then we organize and display the data. So that might be in a table or a graph. Or even in words. And then we calculate descriptive statistics. So some examples that you already know about are mean, median, and mode. Those might be descriptive statistics that just tell us about the data in general. So they would help us understand the center and the spread of the data. So examples that you already know about: mean, median, and mode. Have we talked about standard deviation in this class? Maybe you did in Algebra 2. Standard deviation, I'm just going to write SD for standard deviation. Those are just examples. Okay, and then we need to interpret the statistics. So once I tell you the mean test score was 76.3, then we think about, well, what does that mean? And we interpret it. All right, that section's done. Questions?
Was that accurate, the score average?
It was not, and I haven't calculated that. Done. Describing a problem. Before we start collecting data, we need to consider what the goals of our investigation are. And that will help us decide what variables we need to measure. When we're selecting our variables, we need to consider the relevance to the investigation, right? Like, if I wanted to know how well you prepare for your test, I'm not going to survey you on what shoes you're wearing. It has no relevance. And the limitations to measuring a variable. All right, for example, if I asked you about how well you prepared for a test, you probably don't remember the exact time you started and stopped studying. It might have been better if I asked you to measure it ahead of time. All right, let's turn the page when you're ready, and we'll talk about errors in sampling and data collection. All right, so a census is the most accurate way. Oh, a census is the most accurate way, whenever I get to the top of the page, to investigate a population of interest, but it's just impossible to always ask every single person. So we can conduct a survey of a well-chosen sample. However, no matter how well we choose our sample, there's always going to be bias in that sample. And bias doesn't mean exactly the same thing as it means like in the real world. Like in the real world, if you said that a teacher was biased, you might be saying that they're acting in a certain way towards you, like based on how you look. But bias in statistics just is any time that the sample you choose is not representative of the entire population. And that's going to be almost all the time. Okay, so let's see. Whenever we collect data to estimate a characteristic of a population, our estimate will certainly be different from the actual characteristics of the population, and that difference is referred to as an error. And there are four main categories of error. Sampling error. If you choose a bad sample, that could be sampling error. Coverage error. We're going to go through the types of errors in a minute. Non-responsive error. And measurement error. All right, and if you are fast at writing those down, then you can start reading ahead about what those types of errors are. So sampling error occurs when the characteristic of the sample differs from that of the whole population, which I said is almost all the time. This error is random and will occur even for samples which are well chosen to avoid bias. So if I use a random number generator and I got each of you to choose a number, and say I wanted a sample that represented both boys and girls, but with randomness, I might accidentally choose all 5 girls, and I wouldn't have any boys in my sample. And that would, even though I used a good technique, random sampling, I still didn't get a representative sample. So that would be sampling error. Sometimes it's the fault of the sample, and sometimes it's not. Coverage error occurs when a sample does not truly reflect the population we're trying to find information about. So to avoid coverage error, samples should be sufficiently large. And unbiased. Okay, so you do your best to be unbiased. And sometimes a sample will still be biased, even though you tried really hard not to. If, for example, I wanted to ask students who should be the next president of the United States, I wouldn't go to the Young Republicans Club, I wouldn't go to the Young Democrats Club and ask that question, because that group would tend to answer in a certain way. You would want to ask a more representative sample of the population. Non-response errors occur when a large number of people selected for the survey choose not to respond it. So, for example, say I decided to survey all my students and I sent you all a Google form, but only 5 kids filled out my Google form, right? Then that would mean I would have non-response errors, because some of you would choose not to do that. And measurement error refers to inaccuracy in measurement at the data collection stage. So like if you actually make a mistake, when I'm counting up who said they wear Vans, for example, if you make a mistake, that's a measurement error. All right, let's take a moment to pause and try to digest some of those last few things before we move on to sampling methoding. All right, in general, the best way to avoid bias when selecting a sample is to make sure that the sample is randomly selected. Now, I'm going to show you randomly selected. I'm going to show you in a minute how to randomly select on your calculator, but my favorite random selection is random.org. And that's not what we're going to do today, but you should check out random.org, because their algorithm for randomness is more random than any others. Think about, like, an algorithm is a rule, right? Rules aren't actually random. So a lot of things that pretend to be random actually aren't. Does anybody have like a teacher that has a wheel that spins with a name picker, but it always picks the same kids? Has anybody seen that? I've used a couple, and I think they've gotten better recently, but when they first started making these like wheels that pick people, they would always pick the same kids because they were like using the same rule. So their rule for randomness was not actually random. Random.org is one of the most random sites for randomness, but I'm going to show you how to do it on your calculator too, because you're going to need that. Okay. All right, so we're going to look at 5 sampling methods. They are not all random. So these 5 sampling methods, I'm not saying that these are random. They're just 5 different ways of sampling. So there is simple random sample. There's systemic sampling. Convenience sampling. Stratified sampling. And quota sampling. All right, so take a moment to think about what those might mean. All right, simple random sampling. For a simple random sample of size n from a population, every member of the population has the same chance of being selected from this sample. So it's not like I'm asking whoever can get to the front first is going to be the person who wins the prize, right? That wouldn't give everybody the same chance, because everybody sitting in the front row is closer, right? So everybody has the same chance. Each set of n members of the population has the same chance of being selected as any other set of n members. So that would mean that like Michelle and Simon and Sophia have the same chance of being selected as Gabby and Alex and Avalon, right? Like if I made a set of 3 people, every set has the same chance of being selected. All right, next page. To choose a random sample on your calculator, here are the directions. So let's open up our calculators and choose a random sample. Here's what we're going to do. Just to make it more fun, I'm going to pull up my list. Okay. So we're gonna follow these directions: math, and then probability, and then choice 5. Math, probability, and then choice 5. You see them on your paper, right? So even if you didn't follow that, it's right there. Math, probability, choice 5. It's not working?
No, it puts the different.
Oh, it does?
Goes to this.
It puts random ink from the
Huh.
CR.
Does it have a parentheses on it?
Yeah.
Try putting commas, putting these numbers with commas, and let's see how that works, okay?
Where's the comma?
The comma is above the 7. Okay, so for lower number, I'm going to go back and I'm going to put in 1. That's my minimum. And for upper number, I'm going to put 28. I know it says something else, but there are only 28 of you. And then n equals 3, that means I'm going to choose 3 people. So try doing parentheses 1 comma 28 comma 3, and then close your parentheses, enter, and tell me if that works.
Give you 3.
Okay, so we did this. And now systemic sampling is when you create a list and you choose people at regular intervals. So you have to choose a first person to choose. So say I made a list of all 28 of you. And I said, okay, the first person I'm going to choose is going to be person number 2. And then after person number 2, I'm going to choose every 5th person. So I would choose person 2, person 7, person 12, right? That would be systemic. So an example of systemic is going to be choose every 5th person. Okay? That's just an example. A convenience sample is pretty much just what Kaden told us. When people are chosen because they're easier to select or more likely to respond, and they're more convenient for the experimenter. So like one convenient sample might be if a teacher just surveys their class. And then stratified sampling and quota sampling are pretty much the same thing. It's when you want to make sure that you get people from different populations in your sample. So if I wanted to make sure I had 9th graders, 10th graders, 11th graders, and 12th graders, then I might choose a sample from each grade in order to make sure I have that. So that's this one here. Feel free to read all the rest of the words. And then what I want you to do is read problems 1 and 2 and try those. Okay. Management of a large city store wishes to find out whether potential customers like the look of a new product. They decide to sample 5% of the customers using a systemic sample. Show how it would be selected. So you know that systemic is going to be like choosing every 5th person or something like that. So in this case, you want only 5%. So choosing every 5th person will give you 20%. So let's figure out what you're going to choose. 5% is 5 per 100. Percent means per 100. And so that will simplify to 1 out of 20. So you're going to choose 1 out of every 20 customers. You could start with 1 and choose number 1, 21, 41, or you could start with number 3 and choose 343. 323, 43. But one way to choose your start customer is randomly. So you could randomly choose your start customer. Out of the first 20. So that would be rand int. Between 1 and 20, we want to choose one customer and say you get 7. You might not get 7, right? But say, for example, you got 7. So that would choose your start customer. And then you would select every 20 starting at 7. So you would select 7, 27, 47, every 20th customer. So even though it's a systemic Sample, you can use randomness to choose that first customer. All right, in number 2, we have a certain number of students in every year from year 8 through year 12, and we need to do a sample of 50 students. The total students, if you add them all up, is 752. So when you're trying to figure out how many students from each grade, we're just going to use a proportion. Find the students from the grade divided by the total students, and then multiply that proportion times 50 to figure out how many students. When you do that, you're going to end up with decimal numbers, and obviously, like, you're not going to have 9.4 students, so you just round them, and you do have to look at the end and make sure that they add up to 752, because sometimes when you round a lot of numbers, then they just don't add up right.
What? 752.
You're right, they would add up to 50, right? Yeah, the students should add up to 50. All right, so in year 8, you had 137 students out of 752, and you'll multiply that times the 50 students for your sample, and you're going to get about 9. In year 9, there are 152 students out of 752, and multiply that by 50, and you're going to get about 10 students. And in year 10, you're going to do 174 out of 752 and multiply that times 50 and get about 12 students. And you're going to do the same thing for year 11 and year 12. So 11 was 168 out of 752. And then 121 out of 752. All right, and that's how many the person should choose from each grade. Yes?
Why wouldn't they just choose 10 from each grade?
Because you wanted to represent the students. So in this case, they're not that different in each grade level. But say, for example, a school had like a whole lot of 12th graders and like not very many 8th graders. It would be more representative to have a whole lot of 12th graders in your sample in that case.
Okay.
Okay, I'm going to leave that for a moment and then we're going to go to the next page. We still have quite a bit to do here. Actually, I kind of wish our fire drill were in the middle because there's so much here. Yeah. All right, ready? Next page? No, some people are writing, so let's give them. You have probably already had experience separating data into categorical versus numerical. So this might not be new. A categorical variable describes a particular quality or characteristic, and that data is divided into categories. And that information is called categorical data. None of that should surprise you. And there's 2 examples of categorical data. Quantitative or numerical variables have a numerical value. And the information collected is called numerical data. But there's 2 kinds of quantitative variables. So I'm going to wait for a second to make sure you're caught up, and we'll talk about the 2 kinds of quantitative variables. So quantitative variables can either be discrete or continuous. Discrete or continuous. And so think about the difference there for a moment. Discrete might be if I asked you how many siblings you have. Some possible answers might be 0, 5, 2, 1. Number of siblings might be numbers like that. If I asked you your height, the numbers might be like 5'1", 5'3.5", or my poor son who is stuck at 5'11 3/4. Yeah. So like these numbers, you can see like they're going to have like decimals and fractions in them often. Most people are not exactly 5'6" or 5'8". Most people are somewhere in between. So to take advantage of those that continuous data, we have different kinds of graphs for that. All right, so a discrete quantitative variable takes an exact number value. Discrete quantitative variable takes exact number values, and it's usually the result of counting. So if I ask you how many siblings you have, you would count them. Some examples of discrete variables are number of apricots on a tree or the number of players in a game of tennis. A continuous quantitative variable can take on any numerical value in a certain range, and it's usually the result of measuring. So you can measure the time in a race or the distance a baseball's hit. These are continuous. All right, so I want you to take a moment in number 3 and describe if they are discrete or categorical or continuous. All right, so because you're counting, so it's discrete. The brand of toothpaste used by students in class. Categorical, yep. So you're describing the brand. So categorical. And the heights of the 15-year-olds, we already said that that would be continuous, right? So this is measuring heights. Is continuous. All right, make sure you have that. I'll turn the page. Never ending notes. Okay. All right, here we go. Organizing discrete data. One of the simplest ways to organize data is in a tally or frequency table. So it could be called a tally table or a frequency table. Tally or frequency table. So here's a set of data, and a tally can be used to count the number of 1s, 2s, and 3s. As we read, it says ready. As we read the data from left to right, we place a vertical strike in the column. And so we could use this to represent 5, right? So we group our tallies in 5s so that we don't have to read like a billion 1s. The frequency column summarizes the number of currents of the data. So the frequency column. That's just when you read your tallies. The relative frequency of the data is the frequency divided by the total number of recorded values. Relative frequency. Okay. So I'm going to do this one with you because it'll make it happen a lot faster. The values of the data here are just 1 through 5. So all those numbers are 1 through 5. So we're going to list 1, 2, 3, 4, 5. Okay, we can count the ones. There's 1, 2, 3, 4, 5, 6, 7, 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Frequency is 8. Okay, we can count the twos. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Count the threes. 1, 2, 3, 4, 5, 6. Count the fours. 5. And then count the fives, and there's just 2 5s. All right, so we add those all up, and we found that there are 30 numbers altogether, which makes sense because there were 6 groups of 5 numbers. So there are 30 numbers. To calculate the relative frequency, you just do the frequency divided by the total. So 8 divided by 30 gets you 0.267 approximately. 9 divided by 30 is 0.3. 6 divided by 30 is 0.2. 5 divided by 30 is approximately 0.167. And 2 divided by 30 is 0.0667. All right, so take a moment and make sure you have okay, displaying discrete data. Discrete data can be displayed using a column graph. Remember, which is different from a histogram because the bars aren't next to each other. For this type of graph, the possible values of the data are placed on the horizontal axis, but I'm going to separate them. So I'm going to do 1, 2, 3, 4, 5, sorry. There we go. So I'm going to separate them. And then the frequency of the data values is read on the vertical axis. So I need to make sure I go high enough. So I have to be able to go up as far as number 9. So I think I can do that. That's 2, 4, 6, 8, 10. And then I need to label them. So the left is labeled frequency. That's how many times I got that data point. And then down here, this is the value. And so I'm going to be graphing the data from my table here. So the number 1 came up 8 times. And so I need to show that the number 1 came up 8 times in this frequency table. You can color in the bars if you want. I don't feel like it, but you can. The number 2 came up 9 times. So that one has to go up to 9. The number 3 came up 6 times. Let's see, it's 9, 8, 7, 6. I think that's right. The number 4 came up 5 times. 1, 2, 3, 4, 5. And the number 5 came up 2 times. There it is. All right, so really like that part is just as easy as it was in elementary school. Just making a column graph. But we're also going to learn how to describe the distribution of the data set, which is like the shape of the graph. So when you're ready, turn the page so you can see that. Okay. gonna turn this. Describing the distributing of a data set. So the column graph allows us to quickly observe the distribution or the shape of the data set. So we can describe the data as symmetric. This one is symmetric. Or negatively skewed is when the left side is stretched. It says the negative side. It's not actually negative, but the left side is stretched. It's called negatively skewed. And then positively skewed is when the right side is stretched. And what is happening when your data are skewed is that you're taking a symmetric set of data like this, and you're introducing like maybe not quite an outlier, but a point that's like really near the margins of your data. And by introducing some points down here, it is skewing your data to that side. Outliers are data values that are either much larger or much smaller than the general body of data. So you can see this outlier here. Outliers appear separated from the body of data on a column graph, so there would be empty spaces in between. If an outlier is a genuine piece of data, it should be retained for analysis, but if it's found to be the result of an error, then it should be removed. All right, I think that 4 will be a good one to save for next class, but there might be a few more things to say on the next page. So 4 we'll save for next class, and let's look at the next page. Yeah, let's see what we can get through on this next page here. This is our last set of new notes. Group discrete data. In some situations, there are many different data values with low frequencies, like the number of cars passing a school. So you need to put your data into a meaningful group. It's more meaningful to group the data into class intervals and then compare the frequency of the classes. And so that would be like if I asked you guys your heights, and instead of having a bar for everybody who is even 5 foot and a bar for everybody who is 5'1", I might have a bar for people who are 5 foot to 5'2", and then another bar for 5'2" to 5'4". I'm going to continue with the continuous data, and then we'll be done. When we measure data that is continuous, we cannot write down an exact value, and so we write down an approximation, which is only as accurate as the measuring device. Since no two data values will be exactly the same, it doesn't make sense to talk about the frequency of a particular value. Instead, we group the data into class intervals of equal width. We can talk about the frequency of each class. A special type of graph called a frequency histogram is used to display continuous data. This is similar to a column graph, but the columns are joined together and the values of the edges of each column indicate the boundaries of that class interval. The modal class or class of values that appears most often is easy to identify from a frequency histogram. So you can see your modal class will always be the tallest one.